Think about any gadget you own. Your phone, your headphones, anything. Every single one of them started out as just a spark, a simple idea in someone's head. But how do you get from that spark to a real physical thing you can actually hold and use? Well, today we're going to break down that whole incredible journey. And that question, right there, that's really the heart of all engineering. It's not magic, you know? It's a methodical, super hands-on process that turns these abstract thoughts into technology that actually works in the real world. So let's walk through exactly how it's done. Okay, so before we even think about touching a soldering iron or a single component, we have to talk about the why. Why is actually building something so incredibly important for learning? What is it about doing that's just so much more powerful than only reading about it? Well, it all comes down to this really powerful concept called project-based learning. And the best way to think about it is this. You can't learn how to swim just by reading a book, right? You've got to actually get in the water. It's all about tackling real-world challenges, not just trying to memorize a bunch of facts for a test. I mean, you can read a dozen textbooks on circuit theory, but that one moment, you know the one, where you finally get your hands on the parts, you wiggle a connection, and bam! That little LED lights up for the very first time, that's it. That's the moment the knowledge actually sticks. All right, so you're on board. Building things is the way to go. So what's the first actual step? Well, you've got to choose what you're going to build. This is all about finding a project that really gets you excited, but also, matches where you're at with your skills. And the best part is, there is absolutely a starting point for everyone. You could kick things off with something super simple, like a basic LED circuit, just to get the hang of it. And then maybe you move up to a solar charger or a home automation system. The real goal is to find that sweet spot, a project that's going to challenge you, but not feel totally impossible. And now we get to the really fun part, turning that idea into something you can actually hold. This is the prototyping stage. This is where your design leaps off the paper, or out of the software, and enters the physical world for the very first time. So this brings up a really important question. Hey, can I just simulate everything on my computer? And the answer is, kinda, but not really. You see, as this quote points out, simulations are just that, simulations, they're approximations. The real world is messy. It has all these tiny, stray electrical effects that software just can't always predict. That's why you have to build it to know for sure. So where do you even begin? Well, one of the classic methods has a truly amazing name, dead bug prototyping. And yeah, it's pretty much as low-tech as it sounds. You literally take your main chips, flip them upside down on a copper board so their little metal legs stick up in the air, looking like, well, you get the idea. And here's what it looks like in action. It's definitely not going to win any design awards, that's for sure. But look closely. See how the ground pins are soldered directly to that copper base? That creates these super short, direct connections, which is absolutely critical for high-speed circuits to keep signals clean and prevent interference. But of course, the dead bug style is just a starting point. On the left, you've got that beautiful chaos, but on the right, you see the next step in the evolution, a custom milled printed circuit board, or a PCB. This is how you start to bring some real order to your design. Because at the end of the day, as your circuits get more and more complex, you need a system that's organized and repeatable. Moving from that tangle of wires to a custom PCB lets you build much more complicated, much more reliable designs. It gets you one giant step closer to a final product. This brings us to a very, very modern problem. Back in the day, electronic components were pretty big and easy to handle. But today's high-performance parts, they're microscopic. So how on earth are you supposed to build a prototype with something that's smaller than a grain of rice? Seriously, just look at this. This is a common package for modern parts. Those tiny little metal legs are unbelievably close together. You can't just plug this into a normal breadboard, and soldering it by hand is a massive challenge even for really experienced engineers. Thankfully, some very smart people came up with a really elegant solution: adapter boards. You just solder that tiny little component onto one of these boards, and it instantly breaks out those microscopic connections into larger, more human-friendly pins that you can actually work with. It's a simple but brilliant little bridge between the micro and macro worlds. Okay, so you've built your prototype, you tested it, and it works. Awesome. But you're not done yet. A project isn't truly complete until you've documented it. This is how you communicate what you did, how you did it, and what you found to other people. Now, a formal report can sound really intimidating, I get it, but just think of it as telling your project's story. You give a quick summary up front, that's your abstract, you set the stage in the introduction, then you dive into all the nitty-gritty details, show off your results, and then you just wrap it all up with a nice conclusion. It's basically a roadmap for anyone to follow in your footsteps. And as you're writing, please never forget this classic piece of advice. Don't just tell people about your amazing prototype, show them. Use lots of clear photos, circuit diagrams, and graphs. Powerful visuals are what make your work truly understandable and, honestly, really compelling. So we've gone from the why of project-based learning all the way through picking an idea, building it, and documenting it. Let's zoom out now and tie this all together to see the bigger picture. This right here, this is the entire journey in a single image. You start with something messy, maybe a little chaotic and experimental, and you refine it until it becomes a clean, professional-grade board, just like this one. Every single project you build, no matter how simple, is one more step along this exact path. And here's the single most important thing to take away from all this. The final gadget is not the real prize. The real reward is the experience. It's the critical thinking you learned from debugging a problem, the hands-on skill you built up while soldering, and that deep understanding that you can only get from turning an idea into reality. Which, of course, leaves us with just one final question. You've seen the path from idea to device. You know that every challenge is just an opportunity to learn and grow. So, what real-world problem will you solve next?